right, hello and good morning to those of you joining us, and welcome to part 2 of our AI innovation series here at Jameel World Education Lab. For those of you who don't know me, I am Megan Mitchell. I am acting director for operations and strategy at J-WEL, and I'm here to serve as a moderator today. But what we're hopeful is that this will be really a lively, interactive discussion with folks, chatting with one another, asking questions. Of course, I have questions prepped and prepared, but I am hoping that I become almost irrelevant as people start diving in. So don't hesitate, please, to speak up and share your perspectives. This is actually builds on our first event of the series, which happened last Tuesday on August 6th. And the video is available for that, where we hosted MIT Dean of Open Learning and Digital Learning, Cynthia Breazeal. She's also a professor at the Media Lab to talk about her work and the work that's happening at MIT on applying AI for intelligent agents to serve as learning companions and mentors, and really, the great work that's being done on leveraging social and emotional artificial intelligence is key to optimizing learning for particularly younger learners, with the promise of this transferring to older learners as well. And really, these AI-powered robots, which are exciting and fun to see, can be used as peers and learning companions, because it's really critical that social activity stays as a part of the learning process. But beyond that, Dean Breazeal also really spent a lot of time talking about not just AI literacy, but AI fluency. And what does it mean to not just learn about AI, but learn how to use AI and how to use it as a responsible, actor, and really driving it forward as a learner as well. So with that setup, we have two colleagues of Cynthia Breazeal's, of Professor Breazeal's here, Haywan Park and Sharifa Alghowinem, who will be speaking about the work that's being done. They're doing also, as part of the MIT Media Lab's personal robotics group, and really kind of building on the discussion that happened and what Professor Breazeal presented. And then from there, we've actually asked two of our members to join us as well, from the National Autonomous University of Mexico. We have Mara Pampa Mancilla, and from University of Sao Paulo, we have CJ Isotani. So they will also, they will be responding to what they hear also from Haywan and Sharifa. So this is, hopefully going to be an engaging dialogue and gives you all a chance to really engage and react and respond and share what's happening also at your universities. This is being recorded so that we can share it with our members. But wanted to lay that groundwork, and excited to have you here. So just a little bit of background, first on Haywan. Haywan is a research scientist with the Personal Robotics Group at MIT. Her PhD is from Georgia Tech, and she actually is the co-founder of Robotics, which is a spinoff from some of the work she did at Georgia Tech. And she really focuses on developing interactive social machines that really personalize for their users over long-term interactions, and keeping in mind the unique needs and goals of the learner. And I think, her research agenda is centered around developing those personal robots and agents that are capable of transferring learning from one interaction to another, and utilizing collective knowledge and sensing across intelligent and intuitive interfaces that are embedded in everyday objects. And then we'll hear from her colleague as well, Dr. Alghowinem, who's also a research scientist with the Personal Robotics Lab. And her PhD is in multimodal AI, and that's from the Australian National University. And with this expertise that she has in multimodal AI, she really focuses on the models, modeling human behavior using these frameworks. And issues like mood and behavior recognition, using speech and gaze and body movements to detect conditions like depression or suicide, and deception among learners. So those types of really maybe more subtle things we think of as more subtle cues. And she's also an associate director of postgraduate programs at Prince Sultan University. So she has 8 years of experience teaching computer science topics, and working with students, graduate students as well. So excited to have them both here. Before I return it over to them, they prepared a little bit of a presentation to lay the groundwork and to build on what Professor Breazeal had done in our last session. I would be remiss if I didn't say a few words about Bill von Villian, who is really the person who's in the driving force behind this AI innovation series. He leads a lot of our thinking series here at J-WEL, and has been doing a lot of work with MIT Open Learning over the years. He's actually been teaching at the intersection of policy and technology at MIT for quite a long time. And he has a unique perspective because he was actually the director of MIT's Washington, D.C. office. So advocating for MIT and in the science and technology space and with our government and policymakers, because he spent a lot of his career in Congress supporting our congressional leaders to make sure they were informed and prepared for the types of transformation that was happening. So with that said, I would like Bill to say a few words to set the stage, and then we can turn it over to Haywan and Sharifa.
Sure. Thanks, Megan. Thanks for that good summary. I'll just say a couple of things for about a minute as kind of backgrounders for all of us to think from. I mean, Cynthia's obviously her big message was how personalized education is, how social it is, and how much learning is really social learning in the context of other people. And if AI is going to be successful and add a new tool set, the social and emotional features of AI really need to be made optimal. So that includes emotional engagement with learners, and that includes treating AI really as a collaborating ally. And AI, as Megan noted, will need to be designed to perceive interpersonal cues, to kind of develop a form of rapport and social inferences, and pick up emotional cues that reveal the kind of learner's state of mind. So that means it's going to have to be good at social observation and kind of picking up guidance from that observation. So social AI-powered robotics, which Sharifa and Haywan have both worked on, in turn can be used really as kind of peer learning companions if they're optimized. But she also emphasized that because learning is a social activity for people, teacher engagement is critical. AI is in no way a real replacement for that social engagement and mentoring from teachers. And then the other big theme of her talk was really around AI literacy and fluency. Educating students in the first case as to how to be literate so they understand the new AI technology and its potential uses, but also its limits and the problems that it can cause. So to be good users, they've got to understand both sides of this technology. And she argued that we really need to strive towards AI fluency, where students really learn how to make AI. And this is, essentially in education terms, this is a constructivist approach advanced by educators like at MIT, Seymour Papert. It's really learning by doing. And she discussed how we began introducing this and discussed a lot of tools that MIT has developed for both students and teachers to help bring AI into classrooms. So with that, let me turn it back to Megan and we'll go to the next stage.
Absolutely. I'm just here to turn it now. We're going to hear from our two colleagues from the personal robotics lab at the media lab. So I know Haywan has some slides to share. And we will jump into their presentation, please.
Yeah, thank you, Megan. Thank you, Bill, for the staging. Yes, I have my background, Media Lab space. This is like where people like hang out, and we really emphasize the power of collaboration and just people with collaborations being birthed from just people mingling together. So here's our fun space. Yeah, great to be here. Thanks for the invitation. I'm also co-director of MIT RACE, which is Responsible AI for Social Empowerment. And I particularly lead the AI augmented learning component of MIT RACE, which is about how to use AI, how to integrate AI in education to empower learners, right? So we have also like Hal and Eric, who are also other co-directors, Cynthia being our overarching director of MIT RACE. We also have like parts about like how to bring AI education, like teach about AI, right? And how to empower teachers by professional development, right? And AI augmented learning focuses on how AI can support learning. So how can we use AI for education? So that's kind of like the big picture of MIT RACE I wanted to point out. And also apologies for my voice. I'm just recovering from COVID and I still have like a stuffed voice, so you might hear my voice breaking at times. That being said, I bring you a presentation that goes a little bit more deeper than what probably like Cynthia shared, like our overarching vision last Tuesday. Going a little bit deeper into basically the components that Bill pointed out. That was just a fascinating summary, Bill. So yeah, let's get right to it. So we've been working on this personalized AI companion agent for over 10 years, over 15 years, I'd say. And where we really focus on is how can we bring the powerful like AI tools, but not as just a tool, but as a companion that can really get integrated in your everyday life and be that companion that personalizes to you over time, understands how this student or what kind of a learner this student is, like what motivates the student, right? And really like leverage those like social power to support the learner's motivation to learn, to really build a foundation over a long term, to really set up for student success over time, right? So we are not particularly too interested in trying to instill the actual knowledge part of the curriculum, versus we've been working a lot on how to support students to have a mindset, have an attitude, have motivation, so that they have this intrinsic power to support and propel their learning forward. Because if the students actually have those intrinsic motivation to learn, you don't really have to instill like embed knowledge in them. They will self learn, self teach them, or find resources to learn, right? So that has been our focus. And so that being said, we'll learn more like how social AI agents support those kind of development in especially young early childhood, because we think the school readiness and diversity in classrooms needs to be supported in the right direction. And worldwide now, every learner, when they enter the public school system in the US, depending on the state and district, that happens in preschool, sometimes in kindergarten. Some districts might not even support kindergarten. Their public school system starts at first grade, right? But when they first enter the public school system, they are a unique distribution of their cultural and linguistic background, right? They they might not come from a family where English is their first language, which then that might actually be a factor for them to have harder time being integrated into the classroom learning and interacting with others. And because at that early of an age, interaction is key to learn, right? No one starts to learn and like read and write by just studying the book, right? They learn by socially interacting with the teachers, the peers, people around them. So that's like what we are really highlighting here. Learning is not just about cognitive engagement, it's about social and affective and relational engagement. I'm sure you all had experience where you studied harder for a subject when you like the teacher more, right? So we're trying to really highlight these aspects of what we can bring with social AI, right? So before a lot of the intelligent tutoring system, they primarily focused on the cognitive part of students' learning. But learning is not just about cognitive engagement. Let's bring in social, affective, and relational aspects to learning as well. So like the video is essential to any kind of like presentation we do because we actually install a physically embodied agents in the scene. So take a look at how the children is engaging with this physically embodied social agents.
Nice to meet you. Want to play a story game? Yes. Once upon a time, a little penguin named George lived in the South Pole. Go ahead, you tell a story. I want it to be about a snowman. Ooh. Once upon a time, there was a snowman, and he was alive. I'm a baby dragon. See my wings? Yeah. Will you play with me again later? Yeah. Ooh, hi. Hi. Remember me? I'm green. I remember. Is it your favorite game too? Yeah. Your turn. So the penguins took that bat and put it on the snowman's head. The end. Your turn. I'm gonna tell a story about a snowman. Ooh. Once upon a time, there were two penguin sisters.
Okay, so I'm not sure if you noticed, but this work, the video, the particular video I showed you was done when Frozen was like the kid. So you could like notice actually children like telling a story about two sisters, right? Penguin, two sisters as power of snowman, right? So the reason I'm like bringing up this like old work is because we built a lot of foundational work in our early years of this investigation. And what you just saw in the video, I think if you focused on like how the children is treating the robot, you could also see their development of like theory of mind, right? Like placing the tablet, like, reorienting it so that it's like on the correct orientation for the robot, and then later on actually being on the same side with the robot and sharing these experiences. So why do they engage in such a way? Because this is also not an observation we can take when children are just interacting with a tablet or they're like a smartphone or like a TV, right? They're actually interacting with like a social being. And what's actually happening inside them is, like there are papers that actually saw like why people engage with social robots, these physically embodied agents, in such a different way then they interact with other technologies, right? And they found out that the actual like the brain area that lights up when people interact with a social embodied agent, they're the same regions in the brain light up when they are socially engaged with another agent, a human being, right? So we are just leveraging this kind of impact the social agent have, because we also like get into like, oh, isn't installing robots expensive in classrooms and in homes? So can there be other more scalable and less expensive ways? So we'll actually get to that discussion later. But that's why we are emphasizing this physical embodied agents, because we actually see in the field the difference it makes in terms of students' engagement that also leads to the learning outcome. So in our early investigation, we focused quite a bit on social emotive perception and expression. So like recognizing how the children is engaging, what are their like interpersonal cues that they display to the robot, right? Because then you have to react to it accordingly. Also use that information to personalize the interaction. The socio-emotive expression, like as you saw in the video, we also put a lot of effort in designing the cues that is displayed by the agent, because it needs to be transparent and interpretable by the user interacting with the agent, right? And also that becomes the factor for engagement for the user, right? And then combining those understanding and the expressive cues of the agent, we leverage them to actually learn during the interaction. Or what kind of a learner is this particular student, right? Do they welcome challenges, or do they like more hand-holding and support over time, propelling them to be a more challenge-focused learner, right? And in all of this picture, we really hide this long-term relationship building. So we've seen in the field that students build like rapport and emotional bond with the agent. And how do we actually leverage and engineer for that so that it can actually propel their learning forward, and also in a ethical way, right? So all of the great discussion points that we can get into. And these are all kind of like little projects and capabilities that we did. Not to overwhelm you with a text, but like building a social agent is not just about machine learning. It has to also combine like human psychology, education. So we had a lot of collaborators along the way, a lot of like sponsors, including like J-WEL, that have been working with us to really bring this kind of technology forward. So I'll speed up a little bit here. So this is about like learning how the robot should be expressing and displaying the right sentiment as it interacts with the students.
So the cat.
We also try to understand, because we are working with like young learners, like 5 and 6-year-olds, right? And we noticed that their encoding and decoding of social cues is actually quite different from how adults encode and decode. Like Megan, right there, you are nodding. That's a great back channeling cue. We actually noticed that kids this young of an age rarely nod. It's not like one of their encoded cues, like a cue that they use to communicate that they are engaged. So we need to utilize like different cues. So take a look.
Broke the window, and then it ran through school and peeked inside. He saw classmates.
So we collected this data to train, to recognize and develop expressive cues of the robot, to make sure that when the robot is listening to a children's story, they can feel the robot is engaged to their story, and vice versa. When the robot is telling a story, we also want to recognize the right cues from the kids, to recognize when they're engaged and disengaged, so that the robot can also then perform like different actions as reactive to and responsive to the students' cues. So we did a bunch of studies, and we recognized that we found that when the robot is actually able to recognize and encode and decode the engagement cues, then they are more engaged with the robot, who can actually back channel accordingly to when they are talking to the robot, telling a story. And then the most likely, the highlight part of our research is personalization, right? Because no one learner is the same. Like no two learner are the same, right? Every student learns and they get motivated differently, right? So how can we develop this like personalization strategies for a robot? We can, for example, adapt the robot's personality to the learner. We've done a ton of work on adapting the robot's role. So should the robot be always this like expert, like more knowledgeable peer that always offers information and knowledge to the student, versus can we actually design a vulnerable robot that like asks for help from the student, right? And then can it actually be a dynamic adaptive role that, you know, is like a very natural peer-to-peer interaction, right? Like you can be more knowledgeable in one part, less knowledgeable in the other, so that really brings the building of the reciprocal interaction and relationship. And can we actually leverage that to engage the student and propel the learning further, right? So we had so much fun doing these projects. So this was like a work that we did to really adapt the robot's role to the learner. So when the student is struggling, the robot offers support. Oh, I think lavender means this. Versus when the student, like when the student has knowledge that they want to like demonstrate and they want like, you know, kids love to teach others. So and then that's a point where the robot is actually asking, hey, do you know what this means? Or can you help me with this? And kids like just jump in and they offer their knowledge to the robot. And for the robot, that becomes a moment to learn what the child knows and doesn't know. And also that becomes a factor for personalizing interaction and personalizing the learning for this particular student.
Lavender? I'm lavender. Oh, what are we trying to find? We are trying to find lavender color stuff. Okay. The word was lavender. Yes. And what is lavender though? What's lavender? No, that's blue. What is lavender? Girl, jumping.
Just to pause the video at that point. So what they are actually doing is they are playing like a word, like vocabulary learning game, like I Spy. So find something that is lavender. So they need to collaborate to find objects that are lavender. In the meanwhile, we have these like cameras on the tablet and on the robot that monitors for the child's this expressive and engagement cues. And also the robot, if you like notice, like gazes at the child, gazes at the tablet, is also signaling its engagement and also creating opportunities to observe the child's cues.
I'm sure you will do better next time. I believe in you.
Robot's turn.
Time to perform. Lavender is purple. Yes. Just like my friend.
So there we go. So the robot decided that the child would like need a demonstration and offers its knowledge, right? And when the child is like confident, they know what lavender means, and robot will actually back off. And when it's turn, it's going to like ask for help. And that gives another opportunity for the child to demonstrate their knowledge, practice their knowledge. And over time, we are making this reinforcement, leveraging like reinforcement learning, which basically means the robot gets reward for how the child is engaging well and like propelling their learning forward, thereby understanding that, okay, this child now is like a learner that loves challenges. So even if like the child is struggling, let me back off because this worked better for this child. Versus if the child is, they need like a little bit more hand holding at the beginning, then it learns that, oh, this child like does better when I actually offer more support. So let me give more support to the child, right? So thereby over time, the agent can actually personalize its role and actually adapt its behavior in real time along the way. So graphs, but this is basically showing how powerful the personalized and adaptive learning agent supports children's learning. So it shows that over time, and especially over long term, that we see the personalized robot offered much better support in terms of propelling the learning forward and also in terms of engagement. We also went back after 3 weeks to a month to do like a post test on if the learning actually stuck with them. We actually found that with the personalized robot, more knowledge actually stuck with the child over even after the interaction had ended. So we've been applying this kind of mechanism for adapting robust role in vocabulary learning and like syntax learning, a lot of like literacy and language education, because that is like a foundation to any kind of learning, including STEM education along the way. We also applied it to how kids can how we can foster creativity and curiosity in children. So this like all results like points to how personalization actually works. This is one of my favorite projects where we worked on not actually teaching a vocabulary or anything like that, but really growing their growth mindset, which means growth mindset means it's like a belief of your ability that when you put in enough effort and try hard, you grow over time. Versus a fixed mindset is, oh, I'm born with my skills. Like my parents aren't smart. Probably I'm not smart, right? So how can we actually intervene with those like the internal beliefs about their own ability, right? If the robot is actually showing these beliefs about itself, can it actually transfer and affect the students' belief about themselves? And we actually saw a very strong impact of this interaction. And this work was like really well recognized across our community, education community, because before the growth mindset was studied mostly between parent-child relationship, teacher-child relationship, but not a peer-to-peer relationship, because you can't have a five-year-old actor act to another 5-year-old. But we can because we have a robot. So the robot is demonstrating like how it deals with failure and success. And when it's failing, it's not saying I'm dumb or like I'm not good at this, right? It thinks of it as like a learning opportunity. Same as when it succeeds, right? It doesn't say, oh, I'm so smart. It says like, oh, I put in a lot of like thinking into this, and like this time I succeeded.
So I will try even more. Let's move this piece. I never gave up, even when it was hard. Oh. You are next. Try hard and you will.
So what we actually, during our pilot test, we actually found out the fixed mindset, because we had like a fixed mindset robot and a growth mindset robot condition at the beginning. And we found like how quickly kids actually grasp the fixed mindset, that we had to bring those kids back. So when the robot is saying, oh, this is too hard for me, this is like beyond my level, kids were adapting that so quickly that we had to bring those kids back and actually do several sessions of growth mindset sessions. And then in our main study, we had ditched the fixed mindset condition because of that very reason. And we replaced it with like a neutral mindset where the robot is just, oh, I failed, like succeeded, just talks about its factual like information versus actually displaying the mindset. So we found out that even in a single session, after a single session, that this impact was so significant that we thought of like bringing this result to a longer term, like semester-long classroom. So here we installed like robots in classrooms and did a similar like puzzle activity. Some puzzles are really challenging to like solve, but we measured like how like what kind of difficulty level puzzle the children were selecting over time, what kind of behavior they are adapting.
Great. If my pronunciation is a bit wrong, I'll get better.
And eventually what they actually believe about their ability, right? So I'll skip the first interaction part.
I'll get better as we become friends with rotate pieces with the
Then we later on went back and interacted. Oh, wait, this video doesn't have it. Sorry. We went back and actually interviewed the children. What do you think about like, why do you select a difficult puzzle? Because when they select a difficult puzzle, the robot will ask, why did you select a difficult puzzle? Then kids will actually say, because it helps my brain grow. Like, it won't get me more stickers because we gave out stickers as a reward when they were able to solve the puzzle. But we were actually fascinated. Kids with stickers, you know, like their relationship, right? But they were not dwelling on stickers anymore. They were actually, they would understand that, you know, selecting more challenges and being more welcoming of difficult, you know, challenges. It actually helps them with like growing their brain over time. What we also found out is that when growth mindset was paired with like curiosity fostering interaction, they stuck longer after the robot was removed. So we really understood that power of growth mindset, how and the persistence, right, of like the effort that you put in, that will eventually, and the belief that it'll eventually come back to them, reward them in a longer term. Amazing. Oh, here's the interview. Okay.
So if you were playing this game, which game would you pick?
This one.
This one? Why would you pick that one?
Because it looks like a challenge and I love challenges.
So, if you had to choose which one you were going to try to play, which one would you pick? Which treasure chest? The mystery one? Why?
I like mystery.
You like mystery?
2, 3. Which would you choose? 3? Why is that?
Because it looks mysterious and I want to do something that can help my brain grow.
Amazing.
So if you're
Gives me chills every time I see this. So I want to end this talk with one of the most important aspects that we found in across like our investigation. We actually found that when children rated how close they are with the robot, those children who rated the robot as being close actually decided a very strong positive correlation to their learning outcomes. We also see this not just in, you know, vocabulary learning and things like that, but we see the same phenomena for like instilling growth mindset and other kind of behaviors too. And this correlation was even stronger when the robot was personalized to them. So it actually brought that, you know, personalization. Kids actually feel that the robot knows them, understands them, can like match their learning pace, their learning style, right? So with that, I want to open up for questions, or I will actually hand it off to Sharifa to talk about our AI fluency work. And that will be a nice transition to how we engage with older students beyond this early childhood stage of their education. Okay, thank you so much.
That's great. And for those of you who've just joined us, once we hear from our guests from the MIT Media Lab Personal Robotics Group, we've invited 2 of our member organizations also to share their perspectives on what they've heard and really launch a dialogue. So I'm just for, I know a few people joined us after we started, so wanted to reset. But please, Sharifa, I'd love to hear from you.
Yes, thank you. So my piece is short. I just wanted to touch base on the AI literacy and AI fluency that Cynthia mentioned in the last week session. So we do also a lot of curriculum, like design curriculums that allow the kids to interact and play with AI and learn about it, and for example, creating models and such. So we create, when it comes to, if there is like an overlap between what Hewan mentioned and what the AI literacy is designing, we design 2 curriculums that actually use the robots into the AI development. So we had created a curriculum for Jibo, one of the robots that Hewan also showed in the videos. and attach it to Scratch blocks. So the kids will create an interaction with a conversational agent. They will create their AI models for NLPs, like a natural language processing. There's like, if Jibo asks, how are you? And then your response is a positive or negative. So they would create the model to classify what does the person have said, and then how the robot should interact. So it's a conversational dialogue that they create through Scratch blocks. And also it has elements of AI, like either NLP, or we have the blocks for vision, and then we teach them all of these things. And the other curriculum that also integrate robots is the Doodlebot. This is one of the new robots that we're creating with, and we're hoping that it will be cheap enough to be deployed and be sent to the schools. So, and for that robot, also kids will use Scratch blocks to control its movement. They will draw together, and the robot will be using its vision to navigate. And then one of the curriculums that we've designed is automatic navigation with these robots. Like if the robots, the kids will create algorithms that finds the coins, and so they could compete with the other child robot to who would collect more coins. And that's like a specific curriculum designed for automatic navigation, search algorithms, and all of these, and where the kids would learn these things. When we're not using robots, and I think this is one of the questions that was asked last week, how could people, the schools who doesn't have enough resources, play with AI or use AI into their own things? So we create curriculums for using Scratch, for example, or App Inventor. App Inventor is a mobile, also block-based programming for mobile applications. And they use these with the sensors like cameras or microphone or other things to know what is perception and how to create these models. And that is the AI literacy. In each of these curriculums, we integrate policy and ethics. So kids learns about what are the ethical implications, what are the harms of AI, and they will be aware. One of the new curriculums that we're designing is the digital citizenship, or how the AI could influence their voting, and that was specifically designed for high school, since they're very close to voting in the polls in the next year or so. And then when we talk about AI fluency, it's where how could they use these curriculums or these AI into projects. With these, we have few things, like we have the future makers, where the focus is not the curriculum itself, but the focus is with the projects that they create that has social impact. So they design with their community some apps, mobile apps, that would help their community, where they could have an impact either for the financial or social, or for their own community. Kids come up with amazing projects, and I think they presented the work last Friday. It's a 6 weeks project during the summer, and it's amazing what you could see from those. And this is where we're thinking about how they use AI. As again, we're not designing curriculum, but we're designing the entrepreneurship mindset with this program, and they have mentors that would take their teams week by week into designing their final project. With this, we mostly focus on K-12, but we have also a few curriculums that are for adults, but we don't do undergrad or algorithmic side of things, but it's more like, for example, one of the things we did is like a learning machines curriculum, where it is designed and focused to the leaders who have to implement AI into their workplace, but they might not know enough technical background to ask the right questions before they integrate AI into their workplace. So we do these workshops or curriculums that are specifically designed for them to understand policy and ethics and harms and benefits of AI, and how they could create it themselves. They see it, they navigate with it, and they build it, so they would see what's the error rate that comes with these models and how could they avoid them. Heywan, you wanted to talk about the elderly with robots, so I'll leave that to you.
Do we have time for that, Megan, or do we want to move on to questions?
See if if that gets integrated into the questions, and I would like to give our discussants some time, but thank you both very much. I think this is really, opened up a lot more of the kind of the depth of the work. We had a wonderful overview from Cynthia, but the real depth of the research and the nuances. So thank you very much. Now I'd like to turn to, we have two discussants here from two of our member universities who are going to share a little bit kind of response in what how their work is reflected or not in some of this. So first I'd like to turn it to Maura Pampa, who's with the National Autonomous University of Mexico, or UNAM, which is a little bit easier and rolls off the tongue a little bit more easily. And Maura is, her background is in pedagogy, and really has worked a lot in the conducting research on education issues related to teacher training and performance, identity, and the inclusion of ICT in the classroom, and currently works as a coordinator of management and systemization of knowledge in the education, in the coordination of assessment, education, innovation and development at UNAM. So Maura, can I ask you for your thoughts and just hear a little bit from you to bring the member voice into this conversation.
Hi, thank you, Megan, and it's great to be here. Thank you for the opportunity to share this really insightful presentations that they both have made, and connecting it with Dr. Cynthia's talk. And what Heywan just showed us is how powerful the way AI is introduced is very powerful, and how it's used in the classroom. So, and also not only in the classroom, but in the educational practices, it's really powerful. And that is regardless of the educational level that is being introduced. No, the approach of the social robot allows a whole spectrum of the social emotional aspect of learning, as well as the student engagement. So I think with the videos, of course, it's really powerful how to see the interaction and how everything there's behind those interactions gets to work. So and all the back and forth you have with all the data that you collect, and you go back and then you see some of the results in the interaction. That for a research project must be really mind-blowing and really exciting also for the things that are next to come. And as Dr. Breazeal pointed out in her talk also, well, the importance of being able to make mistakes as part of the learning process, and this role switching with the robot. And it's also very revealing, as well as the growth mindset that it allows the students to do. It's different when, even if it's a social interaction, it's different when you are with a peer or with a teacher, as it's been pointed out. As doing it with a robot, I don't know, you kind of relax that part of the social interaction, and you don't feel as judged. That's what I get from what you were just sharing. And it allows room for that interaction. And as the robot itself makes mistakes, that puts mistakes as part of the learning process, as I said. And that's really, really interesting. And what Sharifa just said is also about illiteracy and this term of fluency. I really like that since the talk of Dr. Cynthia Breazeal, because I hadn't heard that term in particular, and it really reveals the concept really resonates with me, and because it's more than being literature or knowledgeable about AI. I think it brings more to what it is to know what AI and generative AI really is, and how to interact in a way that you really understand what is happening and take advantage of it. I think it also relates with affordances, not only literacy. So it's a broader way of seeing what AI really means, because you can understand that you have to have critical thinking in order to use it, and also the answers that it gets to you when you're using something like ChatGPT or another not robot related AI, but also to understand how is it built, and also by this using these apps and creating apps, but focused on the greater good for these communities and what's been shared about what the work you're doing. I think it's amazing because it transcends the educational process to being put in practice towards society and the greater good. So it's really good. And regarding what we do at UNAM, well, we're also not prescribing what we do to teachers. What we're doing really is just the focusing on teacher and faculty development, and also in student, it's not literacy, but it's also this fluency, as you say, because it's important for us to establish that they are the ones that are using AI, and they are the ones that are introducing AI to the classroom in a certain way. So as you just pointed out, that is really powerful in the way that not only faculty, but students engage with this type of interaction. So it opens the way, or it really determines on how AI is going to work in favor of the learning that process that is going to take place. So I'm gonna stop there to give time to other comments and what's next to come in the menu for today. Thank you, Megan.
Yes, thank you, Maura. Thank you. I'd like to now turn it over to Seiji Isotani, he's a professor of computer science at University of Sao Paulo, and spent some time in the recent past also at Harvard Graduate School of Education and the Berkman Klein Center for Internet and Society. And his research really in mission focuses on the social impact of these types of educational, innovations and educational practices and AI technologies and policy. And with particular emphasis on, what this means in resource-constrained environments and for low and middle income communities. He has a passion also for this, every student receives that personalized support they need. So I'm sure he was watching the different interactions with great interest, and how to best personalize that learning at scale, which is obviously kind of maybe the next frontier. So, but with that, please, can I invite you, Seiji?
Sure. Thank you, Megan, Bill, and Gus for the kind invitation. And hey, Juan and Sharifa for the presentation. So what really stick to me in these presentations, as well as Cynthia's presentations, was how you are able to design the technology thinking about both the pedagogical approach as well as the technical part. So combining the two, I think it's a really good way to reduce potential bias that people from technology usually have, that trying to just designing a technology and see how it plays out in education, right? So if you see many people just using ChatGPT without any pedagogical consideration, this is one of the concerns I have. And many people in the community is speaking out about these challenges of combining pedagogical approach with AI technology in a way that we actually enhance human capabilities to learn and teach rather than just using in any other way. So one thing that when I'm listening to this presentation is, oh, okay, so how can I use all this knowledge that has been built with robots if we don't have robots or if we don't have infrastructure. So the challenge for the developing countries like Brazil and other countries in the global south is that infrastructure is not there. And how can we bring, the question is, how can we bring the benefits of AI technologies into places and for people when infrastructure and how can I say, and teachers are not ready to use AI technologies. So this is a big challenge. For example, we've been working in places like in the Amazon with several different cities over there. And you don't see internet connection at schools. They do have some connectivity with their cell phones, though it's not a strong one, but they don't have computers in classroom. Teachers do not have access to computers in classrooms. And then I keep asking myself, is there a way how we can like bring the benefits of all these real interactions and experiences into those places? And if we think that a cell phone could be a possible infrastructure, can we mimic the same results that Haywan and Sharifa presented to us into this particular device? Or creating a low-cost device that you can actually at scale to use in classrooms where every student possibly have an access to this technology, maybe asking questions or trying to design interactions in the same way. So this when I'm trying to listen and trying to extract all this important research into this content, these are one of the questions I do have. And thinking about AI literacy and AI fluency, that pose the same challenge, right? So imagine students and teachers that do not have access to a computer. So can we teach AI literacy and AI fluency just with computer science unplugged approaches? I'm skeptical about this. So I don't know if you have any like comments or ideas about how we can explore the potential of these technologies in those regions. But I really do believe that to reduce the inequalities and to reduce the gap, we can think about redesigning all these tools and initiatives to actually support these regions. Because if you can do that, then the discussion that Cynthia and Haywan offered to us to reduce inequalities actually will happen if we can actually find a way to co-design with AI in those places. So these are my first impressions. And just a final comments to summarize. What I love about this presentation was it connects well with a framework that Project Zero developed a while ago, where to understand or to improve human learning, first we need to design, to think about who are my students, and thinking about personalizations, social components, creativity, growth mindsets, and so on. It goes exactly in this direction. Then we can think about what students are learning, the components, the content component, and how they are learning, which is all the process and the interactions. And finally, what students can do with what they've learned. And I think this component is still it's missing in the presentation, but I'm sure that you all were thinking about this. So after students have learned and have acquired those skills and those knowledges, what they can do with it. So, and I think somebody, I think was Sharifa talking about digital citizenship, I think goes directly into this direction. So thank you very much. So it was really wonderful to listen, and hopefully you have some ideas about how we can actually use all this knowledge here in the global stuff.
Well, I certainly saw both Haywan and Sharifa giving the adult social cue of nodding to that question. So do you have a response, in thinking about in those low resourced environments, how do we transfer this great work, or what is the time horizon maybe for these types of things to come from a lab to fruition, in a variety of settings?
All right, so let me first lay out the landscape of like robots are expensive, right? But for example, like Jibo, the white robot that appeared in my presentation, that at the time when it was like launched in 2018-ish time frame, the full price was $899 US dollars. Often went on sale until the company like the Jibo INC had closed. So at that time, if we compare that to how much like iPads cost, the cheapest iPad, I was just looking up like apple.com, and it's currently like $349 US dollars, right? So just to give you kind of a comparison price point, that even for these like social robots, they did have come to, and that was what 2018, so that's already 6 years ago. The price has already quite significantly come down to the level of these other smart devices like a tablet. So just like laying that landscape out. And yeah, so there are when we approach and I work with countries that have like lower resourcing than in a typical setting in the US, where we are expecting that when we are installing these devices in schools, we expect the schools have like Wi-Fi, right? Like that's like the one like stable network, and Wi-Fi is like the minimum necessity that we currently perform our work, right? And that is where we like also use, because these robots like more the lower end cost robots, they don't come with like a super computer inside, right? So we leverage a lot of it on the cloud compute, and that's why that Wi-Fi connection is so important. We are using latest like the best like automatic speech recognition API, for example, for especially for children's speech. Then that is all like cloud calls, right? So oftentimes in the current technology that we are working on, we use a lot of those, we leverage a lot of those internet connections and cloud compute, and cloud compute is not free, right? Like every call is a cost, right? Now let's rewind back, because I just told you that we've been working on this field for like about 15, maybe a little more than 15 years, right? If we just rewind back to about 10 years ago, where were we, right? Back then we were developing this, personalization reinforcement models that run locally on board, right? Because there weren't any this powerful like LLMs back then that we need to make cloud calls and things like that, right? We are also leveraging, because like some of the schools didn't have stable network. Especially oftentimes we were given rooms in the basement, and where like even if they had Wi-Fi, there was a very low network connection. And then we were like leveraging offline ASR models on the phones, right? Is the performance on par with cloud APIs? No, but we still were able to develop personalized interactions and models that can run locally, right? And we had to, be prepared when suddenly the school network goes down, but our study and interaction had to go on, right? So we do have, because we worked on this project for so long, we do have the first video I showed you, you won't believe it, but that was like completely offline. The ASR was performed on a local ASR model. The robot interaction, yes, it was a little bit more prescripted of the robot, like saying like you should like say this when the child say this, you should say this at this point in the interaction and things like that. But still, it is a interaction that we can provide, right? We are also always like thinking about scalability, because like still like we show the power of physical embodiment of the social robot and how it brings this affective and relational engagement from the child. Yes, we believe that is the most effective way, the form of AI agent to use in this kind of project. But at the same time, there can be trade-off, because for scalability, we probably want to put something on mobile devices, right? So we also have works that we developed a replica of a physical agent as a virtual agent that lives on the screen, right? We've also done work where there's a hybrid. The kids have access to the robot at school, but also have like this virtual agent when they go home, right? So to provide that continued experience, right? So there are many ways to also like engage. And Julia, I did saw your comment on the chat message as well. And yeah, like we also had a collaboration with organizations like Curious Learning. People there were also so involved with the Learn Laptop for Child project. And these devices go to like areas where there's like just zero Wi-Fi. There's no connection to the internet, right? But the interesting thing about building interactions on those devices, and what like Curious Learning also had pushed through, was developing these, like offline apps that you can't really play it by yourself, right? You have to play with someone else, so that kind of provides setting for that you're actually socially learning with another peer teacher, right? Because you have to work together to figure something out. Even like turning on the device, right? They have to think together, because there's no like online manual that they access. But they also like spread their learning. They develop different forms of how to engage and use these devices amongst themselves. So when Curious Learning went back after a year, they observed that the students there were using these apps that they had like put like about like 20 apps on the tablets, but kids were actually, they invented their own way of how to use those apps amongst themselves, and created like their own mechanisms of like how to collaborate, build like this challenging like competitive interactions amongst themselves, like use that as a mechanism to also propel like physical learning outside the apps, and all different like creative ways that they actually utilize the technology, right? So it's also about designing these technologies in cases where we can't have this like, ideal setting. The social robots can be purchased, embedded, connect to the cloud compute or everything. There's always a design and component that we can adapt, take pieces of the important aspects, and instill and design for that given environment. So Sharifa and I've also got like this J-WEL grant this year to transfer our developed technology that's all developed for English learners to Arabic speaking children, so we can actually install them in refugee camps, support their social emotional learning, and also the school curriculum, right? And in those settings, we are expecting that in sometimes like those cases, we won't have the same setting as in the Media Lab or like public school systems in the US. Sharifa, if you want to add anything.
No, thank you. I wanted to add this statement, but you did, so thank you.
Well, I'm mindful of time, and I'm going to make you promise that you will come back and talk about that at all points in the study, right? And keep
For
us
sure.
up to date, because I do think that is of particular interest to our members, who work across, I mean, I know there's been a lot of work that's gone into working across different socioeconomic groups in settings in the US, but then looking at the next kind of level of accessibility from a connectivity perspective and doing this at scale. I wish we had more time. I have all sorts of questions. I could have dove more into that entrepreneurial mindset and the growth mindset and how you carry that forward. I think there was lots here that we could have unpacked in a lot of different ways, but time is precious and we are at time. Bill, is there anything you'd like to say to close us out, or because we didn't get to hear much from you, and I'm sure you had lots of good questions too.
Seiji, you raised a crucial question, and I'm delighted to hear, Haywan and Sharifa, that you're definitely putting this on the agenda and at a high point on the agenda, because these are crucial questions for how this technology can really scale.
Well, thank you. Thank you all very much for your time, your contributions, your attention, and have a wonderful day, evening, afternoon, wherever you are. Thank you all.
Thank you.